What's that? Same formula? No. Actually, rhombus is a little tricky because if you have, a rhombus is just a parallelogram. So if you have a side of your parallelogram and then a perpendicular height for it, you would use the base times the height. But if you don't have that information and you've got diagonals instead, we can find it with diagonals. Okay? So the rhombus and the kite both use the same formula. So here's our rhombus. And here's our kite. And this formula actually involves the diagonals. So we're going to draw in both diagonals. And it's kind of hard to label this because they crisscross, but this one is diagonal 1, and the other is diagonal 2. I'm not just talking about the small pieces, though. I'm talking about the entire diagonal. And same thing over here for the kite. We're going to draw in our diagonals. So we have D1 and D2. Okay. The formula, because this involves all triangles, shouldn't surprise you that this formula also involves taking half. Okay. So it is half of the product of your diagonals. Okay, so you're going to multiply the diagonals and then take half the result. Now, you don't want to mistakenly use this if you're dealing with a side and something perpendicular to it. Then that is, we're just using the parallelogram formula for that. Okay, but if all you have are diagonals, then you use this formula instead. No, you're multiplying.
Oh, so what, diagonal 1, diagonal 2 on that kite are just, it's not one of the long ones?
No, it's diagonals go from vertex to vertex, always.
Oh.
This is the one.
So it's the whole thing.
The whole thing.
Oh, I thought it was just that.
Okay. And again, you're going to hate me for this, but it's not my fault.
I don't hate people.
There's going to be stuff from chapter 8 that you're going to have to use to find something that you're missing. So let's do the first problem.
Just liking to be treated. Ricky, I don't hate people.
No, no, that doesn't matter. All right. Now, this also goes back to quadrilaterals, and you do need to remember some of your properties of quadrilaterals, because some of the things that you're missing, you're going to have to resort to those properties. This is a rhombus. Okay, but we don't have the entire diagonals. But the property of a rhombus that comes into play is they bisect each other. So if this is 9, then that's 9. And if this is 12, then that's 12. So our formula,
Okay, 25
so we do half of 24 times 18. Should be 216.
Did we just put in our calculator 0.5 times 24 times 18?
Yes, you can. Are you getting 216?
Yeah, I got 216.
We'll say meters. Oh, the other thing I forgot to put in this one, but don't let it throw you, you might have something like that out there. You don't need it. You just need the two diagonals. Okay, couple more. should have, all right, well, we'll find another one that works. Yeah, all right, let's go back to this one a second. What I did wrong, because I was looking at my others, is what if I gave you, we're just going to use that same problem. What if I gave you just that? Okay, because you don't.
Well, is it
Yeah.
Oh.
Now, you still need the diagonals because you're not going to be able to get a height, a perpendicular to this one. Here's the thing. Since these are perpendicular, okay, what you can do is you've got a right triangle and 2 out of 3 sides.
Oh.
What can I use?
Isn't that, cosine?
Use diagonal theorem.
Oh, you can use the diagonal.
Yes. So you would do 15 squared equals 12 squared plus, call it x if you want, x squared. So this would be 225 equals 144 plus x squared. Subtract 144, 81 equals x squared. Okay, take the square root. That's where x equals 9 comes from. Okay, so if x equals 9, that's where we get the other 9 and the 12. Okay. Kind of messed up that example because I gave you the wrong starting information, but do you guys understand? Okay, the last thing I want to quickly look at, since we have a second, is a kite.
What happened?
It's already like.
All right, actually, this is number 16. 16 looks better than the other one I was going to do. Okay, what happens when you don't have the other diagonal in a kite?
The world ends and then a zombie apocalypse.
You draw it in and then you do
Rhombus. Rhombus?
Oh my goodness.
That's a bad rhombus, but we'll draw it in. Since the rhombuses bisect each other, the diagonals, this would be 3 and 3, we know that. And then you'd use Pythagorean theorem to find that. Okay? It'd be 4 because it's a Pythagorean triple, 3, 4, 5. Right? Remember how I told you 3, 4, 5s were handy to know?
So what's 6 then?
6 is the whole diagonal.
Oh.
So 3, 4, 5. Save me some time with that triple just from knowing it. All right, so your homework, make sure you write it down. It's on both boards, 1 to 17, 23, 24, and 31. Okay?
I did the homework.
I'm gonna pass on.